Alright, it's about damn time we got this show on the road. I've been thinking, everybody wants to do something important with their life, wants their story to be told, right? But not many people ever get the chance. How come? I'm thinking it's because we've all been conditioned to believe in that whole hero's journey nonsense. You know, the story where some boring schmuck turns out to have this special hidden power. Then there's this older, smarter person who shows up. A guide who recognizes the hero in waiting, helps them train their power and rise from a life of ignorance and boredom so they can go off and save the world. Yeah, that's a load of bull honking. Look, you don't have a unique hidden power, okay? Oh, you have a hidden power, alright, but it ain't unique. Everybody's got unrecognized potential, see? Nobody's automatically more eligible for accomplishment or fulfillment than anybody else. And if nobody's naturally special, that means that nobody else is out there recruiting the ones chosen for destiny. So don't expect that they'll hold hero casting calls in the street. You can't wait to be discovered if nobody's looking. No sir, if the doors of opportunity won't open, you don't wait around for opportunity to open up. You break into that sucker's house. You throw a grappling hook up opportunity's wall. You climb in through the window, stroll into the pantry, and eat all of opportunity's chocolate frosted sugar bombs for wasting your damn time. That's the reason I'm doing all this, to endorse cat burglary, or promote self-actualization, or some shit. So what's this all about? The deal is, I've spent most of my life filling my head with things I'd think would be useful, or things that would help me, or things that just seemed interesting. How come? Was I building myself into a better person, or was I preparing to pass what I knew on to other people? Am I the hero in training, or am I the guide? Yeah, maybe I'm a little bit of both. Maybe this series exists as much for me to document my own growth as it does to share what I know with people. Or maybe I'm neither, just a guy standing in the kitchen helping himself to a bowl of diabetes-inducing chocolatey goodness while he can. Either way, I get to have fun. I'll start by talking about the things I chose to study in school: math, science, engineering. That ought to provide enough material for about a decade or two's worth of episodes. Once I'm finished with that, I'll soapbox about whatever else I managed to cram into my head. I figured that I'll run out of years before the world will run out of crap for me to rant about. Let's get started. This is Animus Anthem. Okay, welcome to your first step on the path to building a smarter you. Math. I know, it's not popular, but we gotta start somewhere, and we need math to do science. Plus, I can tell you from first-hand experience that it's not as scary as people think it is. Why do I say that? When I was in elementary school, my teachers told my parents that I was bad at math. They probably had a more diplomatic way of saying it, like, Alex really struggles in this area. But the message was clear. They had no confidence in my abilities to do numbery stuff, and their lack of confidence in me made me lose confidence in myself. I was behind the other kids in math for pretty much all of elementary and most of middle school. 20 years later, here I am solving the three-dimensional Schrödinger equation in spherical coordinates for hydrogenic potentials, while my old teachers are still teaching multiplication tables to third graders. Moral of the story? Don't let bad grades convince you that you're not smart enough to do math. In all the years I've been learning science, I've only needed 6 types of math. That's it, just 6. Want to see what they are? Well, I could just list their names, but here's the problem. The names suck. I really do not like the way people name the branches of mathematics. So I invented my own names for them. If you're a beginner at math, you might find my simplified names a bit more approachable than the conventional language. The downside is that if you only use my names to describe each subject, nobody else is going to have any idea what the devil you're talking about. So I've come up with a compromise. I'll introduce each subject first by using my name for it. Then, in the interest of being fair and objective, I'll also explain the stupid, nonsensical, idiosyncratic names used by the rest of slack-jawed human civilization. Alright, let's go. Counting math. When you figure out how to count stuff, you can add and subtract. When you figure out how to add and subtract, you can multiply and divide. That's it. That's all there is to this subject, just those 4 counting operations. Greek people didn't really invent counting, but they did invent having a cool language that everybody wanted to copy so they'd sound cool when talking about math in front of their friends. The Greek word for number or counting is arithmos, so the subject was called arithmetic. Go figure. Solve math. Your friend lent you $20. You paid 14 of them back. You want to know how much you still owe. 14 plus the amount you still owe equals 20, so all we have to do is, oh sweet fancy Moses, we're taking the equation apart. And now we're putting it back together using counting math. And now we've solved it. And that's this subject in a nutshell. You solve the equation by taking it apart one way and putting it back together another way. Some Persian guy wrote a book about this subject 1,200 years ago, which loosely translated was titled Rules for Taking Stuff Apart and Putting Them Back Together. The Arabic phrase for putting stuff back together is al-jabr, so the subject was called algebra. Shape math. You're a construction worker and your boss tells you to make a building in the shape of a triangle. Sure, you know what a triangle looks like, but how long do you make each side of the building? If one side's too long or too short, everything won't fit together. How wide's the angle between the sides? If the angle's too small or big, that won't give you a triangle either. It would be really embarrassing if you got halfway through constructing the thing before realizing that the sides didn't meet, or that you ran out of space because the land you're building on was too small. To avoid a $20 million mistake, the smart thing to do would be to measure out the land first. The Greek words for land measuring are geometria, so the subject was called geometry. Not that it's only useful for land surveying, there's a bunch of stuff you can do with shapes. But in the 2,700 years since then, it never occurred to anybody to change the name. Gamble math. There's a game where you pay $1 to roll a 6-sided die. If it comes up as a 6, you win $6. If it comes up any other number, you get nothing. Should you play? And the bigger question, if you play for a really long time, will you end up overall with more money or less money than what you started out with? This is gamble math. You count up all the possible outcomes, assign a value to each one, and use that to guess what's the most likely to happen. It's basically just counting math with a dollar sign at the end, but we decided to give it its own name anyway. Probability, because you're trying to work out what's probably going to happen. There's also the opposite of gamble math, where instead of being told how the game works and trying to guess what the outcome will be, you're told what the outcomes of the game actually were, and you try to guess what the game was, and whether or not it was fair. This might be of particular interest to an IRS agent, a representative of the government who has access to a truly scary amount of information about how much money everybody makes. Since the information can be easily collected by and influence the policy of the heads of state, it's called statistics. Statistics is just reverse gamble math, but you say potato, the Washington think tank says potato. Tiny math. Let's say you're standing on this hill with a funny curve to it. You walk forward 1 foot and you find that you've gone up by 3 feet. So a difference of 1 foot forward produced a difference in height of 3 feet. You divide the two differences to get a ratio of 3. Then you decide to repeat the experiment, but this time you walk only half a foot forward. You find that you go up by 1.25 feet, so now the ratio is 2.5. If you walk 1/10 of a foot forward, the ratio is 2.1. 100th of a foot forward, it's 2.01. 1,000th of a foot forward, it's 2.001. The ratio keeps getting closer and closer to 2. So it seems that if you were to move forward by some tiny, tiny step, the amount you'd move up would be about twice that much. You could try to do the same experiment at every point on the hill to see what ratios you got there, but that sounds really tedious and involves entirely too much walking. It turns out that you don't have to do all that work. With the help of some solve math and creativity, you can predict exactly what the slope is going to be at all points on the hill without having to do any walking at all. Good deal. That's what this whole branch of mathematics is about. Taking the ratio of two tiny differences. You tweak this number by a tiny little bit, and you see how much it changes that number. Since it's all just a matter of tiny changes, I like to think of this as tiny math. Tiny math actually comes in 2 different flavors. What we just saw involves dividing 2 really small differences, so I call this one difference tiny math. But let's take a look at the other kind of problem, one that involves sums. Let's say somebody asks you to find out how much space there is inside this curvy shape here. Well, I don't have a clue how much space is inside a shape like this, but I do know how much space there is in this here box. I learned that from shape math. And I know that the box is smaller than the curve since it can fit inside. Therefore, the space inside the curve must be something just a little bit bigger than the space inside the box. How much bigger? Well, I can get a better approximation if, instead of using one big box, I add up the space contained in 2 smaller boxes. Now it's an even tighter fit, so I got an even better approximation. I can keep doing this, adding up the space inside a greater and greater number of smaller and smaller boxes to get a better approximation until I see what value the sum seems to be approaching. So I'll just call that my answer. So this is a different kind of tiny math. In the old form, we kept taking smaller and smaller differences to get closer to our answer, so we called it difference tiny math. But here, we add together lots of smaller and smaller things to get closer to our answer, so we'll call it sum tiny math. What's the relation between difference tiny math and sum tiny math? With the first, we're dividing really tiny differences, and with the second, we're adding really tiny products. It almost sounds like one is the reverse of the other. Surprise, they are the reverse of one another. Math teachers around the world will now hate me because I just spoiled the biggest plot twist in all of mathematics. Ha ha! The ideas aren't really that hard, but the names that people use to describe them are terrible. Since we're adding or subtracting, in other words, counting lots of tiny things, the name should have been something that reflected the idea of counting tiny stuff. But the European guys who came up with this subject 300 years ago decided to give everything Latin names because they thought it sounded cooler. See if you can follow this screwy line of reasoning. Romans used to count things using small stones or beads called calculi. And a fancy word that means something infinitely tiny is infinitesimal. So instead of just calling it tiny math, they decided to call it the calculus of the infinitesimal, like you're adding lots of tiny stones together or some crap. Anyway, that proved to be too much of a mouthful, so they just shortened it to calculus. For all the good that name does at communicating what this kind of math is about, they might as well have just named it calculator or abacus or bar tab. Anyway, they called difference tiny math differential calculus, which I guess makes sense, but instead of calling some tiny math something like sum calculus or additive calculus, they settled on the name integral calculus. Integral just means added together, but now people will need dictionaries in Latin and English to figure out what the hell you're talking about. For crying out loud. Solve tiny math. You remember how in solve math we had equations that could be rearranged and solved by using counting math? Well, there are some other types of equations that can be rearranged and solved by using tiny math. So I think of this subject as solve tiny math. Some lesser mortal decided to say the same thing I just said in techno-babble instead of English. Because the subject is about equations that can be solved using differential calculus, the subject should be called differential equations. Yeah, whatever. So that's it. Those are the only 6 branches of math I know so far. Counting, solving, shapes, gambling, tiny stuff, and solving problems with tiny stuff. The only difficulty is in the language used, not the ideas presented. Also, those 6 are pretty much all you need for a sturdy foundation for science. It is almost spooky just how much you can do using only those 6 tools. Okay, can we finally start learning stuff instead of just talking about learning stuff?